Okay, today's I'd like to draw some simple structural formulas. Let's start off with one everybody knows, water, H2O. H2O is the chemical or molecular formula. It tells me how many atoms of each element are present in one molecule. The first thing we want to do is we want to count the total number of valence shell electrons from each element as assigned by the subscripts. So hydrogens have one valence shell electron. With two hydrogens, that's going to give us two valence shell electrons that we need to work with. The oxygen is from group 6, so that's 6 valence shell electrons, and therefore we're going to have a total of 8 valence shell electrons that we need to distribute around our structure. Hydrogen can never be the central atom in a structure. Oxygen can, because it can form two bonds. So oxygen will be central, so I'll put my oxygen, and then I'll put two dashed lines representing two shared pairs. So that'll take away 4 of the electrons. We're now left with 4 electrons. And I'll attach my hydrogen. So what I've created here is a skeletal structure. The hydrogens now have their duet. Remember, hydrogen and helium can only have a maximum number of 2 electrons shared. So both of these hydrogens have now completed their duets. They're very happy. And now we have to finish the octet for our central oxygen atom. And I'm going to use up the last 4 electrons by placing lone pairs onto the central oxygen. Now, a helpful hint for a lot of students when you're drawing Lewis structures at the start is basic non-charge bonding patterns. The basic non-charge bonding pattern for a hydrogen atom is one dashed line. So hydrogen should never have more than one dashed line, and you're not going to see lone pairs because, again, it only has a 1s2 shell. If we look at the bonding patterns for oxygen, the non-charge bonding patterns for oxygen, we're going to have one pattern similar to what we just drew, where we have 2 single bonds and 2 lone pairs of electrons. That's one possibility that you see quite often. And then the other one is 1 double bond and 2 lone pairs of electrons. So these are both very typical bonding patterns that you should recognize when you're drawing your Lewis structures, as long as you're not drawing charged or ionic structures. So again, counting the electrons, 2, 4, 6, 8. This valence shell would be complete, 2, 4, 6, 8. And these are our lone pairs or non-bonding electron. Lone pairs or non-bonding electrons.